Am I audible? Good morning. Sorry for the last three classes. Um, Actually, I had a family emergency. My father was diagnosed with um, heart attack, so I had to wait. I had to take him to the hospital, get the surgery done, and all those things took 2 days. So Monday and Wednesday, I was not able to take the class, and then yesterday I was having. Was How was him now, sir? He's good now. He's doing good. He's doing good now. Uh, and yesterday I was having a stomach ache. So, anyways, today we'll start fresh. Uh, yeah. Mm-hmm. Let me bring out my notes and we'll get started in few minutes. Maybe 2-3 minutes we'll get started.
मनीष काहू करे हेचकी लग रहा
Let's wait for a few minutes. I don't think anyone is joining. I mean, I don't think anyone else is. Okay, Parag is joined. Okay. I don't think anyone else is going to join anytime soon, so we'll get started. We'll spend few minutes in the starting of today's lecture talking about databases. Okay? Good morning, Nitish. Let's try to understand where does the database sits. So you have some clients. I draw them like a computer. Like the screen that you're seeing at your computer right now is a client. And there is a server which sends the data to the client. And there is a connection between client and server. Client sends request and server responds to it. But server is like any other computer, like your computer. When you turn off the computer, whatever whatever was in the program running right now, whatever was in the RAM
इधर आ इधर आ
gets deleted. There's
इधर
nothing that is stored in the RAM. So you need a storage for your data, and that is where databases come in picture. Okay,
उधर
database
ठंडा
comes
है
here. It's a backend to the backend. Okay, so server stores the backend, and there's a storage for the data, which is database. Everything clear till this point? Okay. Now let's look at what kind of data do we store generally. Like there are two types of data that you will come across. One is the structured data, and the other is unstructured data. I mean, there is always some structure in data. You can say unstructured data is structured in some way. But what I mean, what these two terms mean essentially here is uh, structured data can be stored in relational databases. Relational databases. Any data that can be divided into tables is structured data. But a data like, so example is customer profile. Every customer has a profile, they have a username, they have a mobile number, they have an email address. All that can be stored in a database, which is structured data. But there can be unstructured data. For example, blogs, or maybe you scrap some website is scrapped, or click stream. Look at the click stream of some user, or any other data. For example, this whiteboard that you are seeing, whiteboard that you are seeing here only, are also example of unstructured data. There's no structure in this data. Like I'm writing everywhere, JSON is an unstructured data. This is typically stored in JSON or BSON, or it can also be a graph. It can also be a key value pair. Lots of keys with values are associated with them. So all those things come under unstructured data. Is the concept of structured and unstructured data tables can be formed. No, sorry, this is not Jamboard. This is not Jamboard. This is only the website that we are doing. You will get its link on Relevel itself. Current. I'm writing on Relevel right now. Tables can be created. I don't get the term click stream and web scrap. Yeah, I'll explain that. So click stream is basically, Vishal, for example, there is some analytics or marketing analytics that you want. Suppose you have a website, okay, and you want to understand the, okay, so you want to know where they are clicking on your website. So they will come to your website, they will click at, suppose this is your website, they will click here, 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 here. So what you will have is a stream of data which tells you whatever they have clicked on, and then you will have data around, I mean, you will get a constant stream of data for every user as to what activity they are doing on your website. Based on that streams, every user's stream, what you will do is you will create your analytics about your users. So that is called as click stream, Vishal. Websites do it, like Amazon do it extensively. They try to know what is the customer behavior, how they can improve their website, all that stuff. Okay. And web scrap is, suppose I have some website like a news website, and I want to get all the news in a PDF format. So what I can do is I can run a beautiful soup script. Beautiful soup is a Python library. You can learn a beautiful soup script on news website, and you can get all the news from there into a PDF format. So that is called as web scraping. You can take data from website using robots, using bots, and they will give you all the data. Suppose you want to store the whole Wikipedia into a PDF, or Wikipedia related to a topic on a PDF form document. What you will do, you will go to that website, there will be a script you will run, and it will download all the HTML and then scrap it, or basically format it in a way that you can read. So that is called as web scraping. Does that make sense, Vishal? Yeah, I have heard about. I am yet to explore it further, Chat GPT, but I have heard how well it is doing these days. Yes, Ankit, that is true. I am yet to explore it further, but it's on my bucket list to go through Chat GTP. Yeah, it's crazy. Exactly. Uh, GPT GTP. What is GPT? GPT is there is a model. This is a model in. Okay, so basically this is started with GPT-1. GPT-1 was there, and what it was a model that used to do natural language processing (NLP) based task, basically text processing based task. So you tell him something and it will do something for you. For example, if you wanted to write code, it will write down the code. So now what with the Chat GPT, what has happened is you can just tell him to write code for a given application, and it will write the code for you. You don't have to write the code yourself. You can just tell the Chat GPT that that this is the code you have to write, and it will write for you. What they have done is they have trained it on a huge data set of code, a huge data set of code, and then they have created this model which can then generate code for you. So this chat is like a bot that has yeah. GitHub Pilot was good, but it was not. GitHub Copilot was good, but it was not the most interesting one. Like, I mean, it had problems. It was giving uh, all kinds of errors, and it was not that good. But I think ChatGPT is, of course, making a lot of news. Let's see what it has in store. But what will happen with this is, students, what I can think of right now is maybe the basic SD1 jobs will go away. So, uh, but SD2 and SD3 jobs will be what people will be left out with, because SD1 work can be done by a computer. Anyone can write the module for you. You just give the command. It is still like 10 years from now, but in 10 years there will be a possibility that you can just give a command that I want this module, and that module will get written in the most optimal way. And then you can just look at bunch of modules from the top and try to see how they all fit together. Let's see what happens. We'll have some new opportunities coming up. It can't be problem solve only write code. It can't problem solve only write code. I mean, in computer science, in the industry, what will happen, Archit, is there are not that many complex problems that are there. Problems are usually very simple. You want a kind of router, or you want a particular kind of solution. But one thing it can do obviously is you don't have to search on Git, Stack Overflow or something. You can directly give it a instruction and get a idea about what kind of code you have to write. Let's see what it has. I'm yet to explore it further. Okay. Anyways, NLP is making a lot of progress. Recently, what has happened was people have started mixing the two fields, the computer vision and natural language processing. There were uh, there were there was a model called as transformer, which was for NLP,
मनीष मरीन
and it
कंबल
has
पे
been
खोचा है भाई उसको
transferred into computer vision, and people are doing much of computer vision, and people are doing a lot of good work with this. Anyways, those of you who are interested in this machine learning stuff, try to explore opportunities as machine learning engineer. That's a very good field that you
चलो
can
मनीष
go
बस
ahead with. Like the level that you have right now, you can go for machine learning engineer. You just have to learn basic of machine learning from any course or book that come across.
उठा उठा उठा
Anyways, machine learning engineers
उठा
will be in high demand in coming days because all this development in machine learning will change the landscape of software development. Okay. There is one more type of data. It's banned on Stack Overflow. What is banned? Uh, to use ChatGPT. Write code on. Okay. Okay. So people might be answering Stack Overflow questions using ChatGPT. That might be the case. They will look at the question and try to answer using ChatGPT. Okay. Anyways, thank you for letting me know about that, Archit and Ankit. Let's get back to the class. No more Chat GPT. I'm banning Chat GPT in the class as well. Let's get back to the lecture. Oh my god. I have been laughing after 9 days now. I was so stressed because of my father's condition. It's been 4 days since I have laughed. You guys make my life better. Okay. Uh, okay. So there is one more. There are two more types of data. One is semi-structured. Sometimes there is some structure. So what we call as JSON data is basically semi-structured. There is some structure. Same JSON data, XML or HTML document. They have some structure involved, but they cannot directly be translated into tables. So that is semi-structured data. You will come across this kind of data in more detail very soon. Okay. When we will develop our app, we will have semi-structured data. We will not have unstructured data as such. So that is the basic funda behind data and databases. Now let's spend some time revising our. Today's lecture is on NoSQL databases, but to understand NoSQL databases, it's very good that you understand relational databases first. Because if you understand them, then you will understand the need for NoSQL. Okay? What happens with relational database or SQL based databases? Uh, databases is this. There are relationships. What is a relationship? Suppose there is a customer. You are a customer to Amazon. Customer. Suppose there is a customer, say Hariharan. Haran. And he buys books. Okay. He buys book 1, book 2, and book 3. He buys 3 books. Now there is a relationship between Hariharan and books. Hariharan is the customer of 3 books from my bookstore or from Amazon. Okay. This is called as relation. Now in relational database, there will be a customer table which will have name and say ID. Let's say the ID is 01 and name is Hariharan. And there will be a order table which will have book ID and customer ID. Okay, and now you will have book 1 book 2, book 3, and customer ID as 01, 01, and 01. Okay, and this is called as relationship. This ID is same across these two tables. Okay, so you can do joins on these two tables to figure out what are the books that Hariharan bought. Yeah, this is called as foreign key, and this is called as primary key.
Mariam, light ko lang na, billi
But the
hai,
more
kya?
important point is, if there is a relationship, I should be able to structure
Charge
it
kya
into
na?
tables. Does that make sense? This is very similar to what you have learned before. Vivek, are you following? Vivek? Vivek, are you in the class? Not in the class? Okay, he's in class. Okay, sure. So this is one property of relational databases. The second property is data is consistent. What that means is, if I somehow change if I change the name of Hariharan, suppose at customer ID 1, I want to save Ravinder. Ravinder is the name of customer with ID 1, or Hariharan decides to change his name, then that is going to change at a single place, and that change has to be consistent with all the table. It should not happen that tomorrow book 2 has a different customer and book 1 has a different customer. Both of them should return. Whenever I try to know who is the customer of book 2, it should be same as the customer of book 1. So what it means is, when I change data in this table, it should be consistent across all the tables. It cannot happen that I change at one place and in another place it is not changed. This is typically due to the fact that every data is typically stored at one place. This ID might be changing, that is one thing, but every atomic value or every transaction that has happened will be stored only once. Okay, so basic idea is everything is consistent in this database. And then there is asset property, which is whenever there are transactions that happen on my database, they should be consistent. They should not be inconsistent with each other. So that means if a transaction starts on my database, then the database is logged first, then I make the changes, and once the once the changes are over, I commit it and then I unlock. Okay, so everything happens consistently, cleanly, very very well structured. You will not have surprises in SQL databases. Okay, following so far: data consistency, ACID transactions. Okay, is there any question? If you have a question, please ask. Yes, Vivek. ACID transactions are basically atomic, consistent, isolation, and durability. You can think of it like this: if I make a change in my database, either the whole change will get executed or the whole change will not get executed. It will not be in a hanging state. Okay, either the name will be Hariharan, and I will say I have not changed the name, or it will be Ravinder and I would say I have changed the name. The full form of ACID is atomic, atomicity, consistency, isolation, and durability. It means that whatever change I make have to happen consistently across the data. They should be happen in isolation. There should not be two changes that happen simultaneously. Every change will happen either completely or not completely, or at a time you can only change one thing in the database. And the change is durable. Either it is successful or change will be reverted. Yes, exactly, Ekta. That is what ACID transaction means. So that is the basic funda behind relational databases. And since you already have done basic SQL based programming, you know these things very well. Now the question arises, if you have this beautiful this beautiful database, why do you want to change it? Okay, and there is one more question, when should you use this data set, this database, which has such a good quality of security and reliability? It has very good security, it is reliable. When do you want to use this? Typically in banking systems, these kind of data sets, databases are very important, because what you want to know, make sure in bank is everything is consistent. If I deposit 100 rupees, I want to make sure that I have deposited 100 rupees. There should not be inconsistency in my account. Even for 2 minutes, if there is an inconsistency, you get panicked. So okay, I'll tell you. Okay, Vivek and Ekta, those are few who are thinking about what is asset transaction. Let me give you an example, and it will become clearer. So, how many of you have used Paytm or Google Pay? Just clap or do hand. Yeah. Okay. So now, if you have done, which cannot be. Uh, Okay. Now what will happen is, suppose you have Google Pay. It has happened a lot of times. If this have happened with you, then you tell me that you try to make a transaction and it failed, and you are not able to make the transaction. Has this happened with you? Can you happen? Can you just do a thumbs up for that? Now, how many of you have done? How many of you have done likes on Facebook or LinkedIn? Have you ever clicked the like button on Facebook or LinkedIn? And has there anyone now do a namaste sign or something? Has there anyone who has clicked the like button and like button has said you cannot click me, or I cannot work with you? That will never happen. Like button will always say you can click me. Like button will never say you cannot click me right now, I'm busy. Okay. So, or for example, this UI that you are facing right now, whenever you click on a button here, whenever you click on an emoji, it is getting triggered. It is not like you click on the emoji and emoji say we cannot transact for you, or it is not getting clicked. It will click every time. Similarly, if you go to Facebook and click on like button, it will click every time. There might be an error on your network, but that is but the server will always work. It will not be like server is down and we cannot let you click like button. So what is happening in here is, in banking system, if I'm depositing 100 rupees, unless the deposit happens, unless you have deposited and the balance is changed by plus 100, unless that happens, I will not say that my transaction was successful. I'll say my transaction was a failure and back to the normal state wherever I was. Suppose I had 1,000 rupees, I will be back to 1,000 rupees. I will not had 100 rupees. Or I will add the 100 rupees and I'll say that there was success. There are only two cases, either success or failure. Okay? But in Facebook like button, this is not the case. Facebook doesn't care if 100 people have liked your post. Facebook don't worry about whether it is showing 99 or 95. Eventually it will show 100. If 100 people, eventually it will show 100 likes if 100 people have liked it. But in the intermediate state, it will show 95 and 99. And that is when Facebook can say, I will always allow people to like the button, but I'll take my time to figure out how many people have liked it, how many people have disliked it, and there might be inconsistency in way people look at it. Okay, suppose there are people living in London and there are people living in New York and New Delhi. The people in these three places, if Michael Jordan makes a tweet, all three of them will not see the same number of likes on his tweet. Typically, they will see different number of likes, and these numbers will change over time. Finally, at a very later state, maybe after 5-10 minutes, all of them will start seeing the same number of likes. and that is called as consistency. There is no consistency in the number of likes on tweet, but there is consistency in your bank account. Would you like to have a bank account where when you check in Delhi, there is a different account balance? When you check in Bombay, there's a different account balance. You will not let that happen. So that is where you will need relational databases, because relational databases will make sure that uh, you will have consistency. Okay, is the concept of consistency clear? Does it happen? Why does it happen with likes? Yeah, I'll explain that, Vishal. Today's class is all about that mechanism. Why does it happen with likes? Why do Facebook allow that inconsistency? Yeah, today's class is all about that mechanism. So here is a question: if relational databases are so good, why do we need them? And the key disadvantage of a relational database is horizontal scaling, or basically scaling. Scaling is the key disadvantage of relational databases. What you will typically see in relational databases is, if there is a database, it will be stored in one machine or one big server. Okay, SQL database will be stored in one big server, and whenever you want to increase the size of the size of your database, you have to buy a bigger server. You can do sharding and other mechanisms, but it is not trivial to do horizontal scaling or a scaling after a point. Do you remember the horizontal scaling concept that I have discussed in the last class? Horizontal scaling. Okay, so it is not possible to do horizontal scaling with SQL databases trivially. It is not easy to do it. You will need a lot of manpower and a lot of understanding. Although there are cases, there are some services that are coming up, but they are at the bleeding edge of technology, and I don't think they will succeed as well as other technologies. There are some technologies where they use SQL and they are scalable, but mostly when scale comes into picture, SQL is not good. It's not a good choice. You cannot scale after a point. You can scale till the some point, but it becomes typically difficult to scale SQL databases. And can you see why it becomes difficult? Can you see? Suppose I have a big table. And what I want to do is, I want to save half of the table in uh, one half of the table at one machine, and then the other half of the table in another machine. Suppose I do this. What is the problem that will occur in this case? If with SQL databases, what can go wrong? If I save half of the table in one machine, machine number 1, and half of the table in machine number 2. Please repeat once. Well, the question is, suppose I have a SQL table, a large table. A large table is there, and I want to save half of the table in one machine and half of the table in second machine. Uh, Inconsistency between two, that can be a problem. But what is the general use of case? Suppose this is my customer table. If one machine goes down, the information is. Can you give one word answer? Just one word answer will give you the case where, suppose I have customer database which I have converted into two machines. Okay, mapping needs to be done. Mapping may be a problem. What is the bigger problem? There is one use case where it will cause havoc. Like, you will not be able to make head and tail of this. Time will be more accessing data. Suppose this is customer table and there is order table, and suddenly you want to know which customer has ordered what. Now what will happen? How will you do the join? Have you thought about it? How will you do a join if tables are on two different machines? Suddenly join becomes no proper. Yeah, mapping. You have to do mapping. You have to do a lot of work. Join will become extensively difficult. Yeah, server using a different server, that you have to use a third server and take a copy of the data set and maybe do a join there. Join will take infinite time. I mean, it will take a lot of time just if the table is divided into two machines. You can do sharding, you can do some techniques, but uh, the overall mechanism that happens in the table, and if you have ever worked as a business analyst, you know that you have to do like three or four joins to get some data. Okay, sometimes people are doing three or four joins and suddenly all the tables are on different machines, and each of those tables are on multiple machines, and it becomes tremendously difficult to do the join. Okay, suddenly this will the pic let me draw the picture that you have. Suppose you want to do the join of table 1, table 2, and table 3, and suddenly what happens is table 1 is on this machine. uh, One server share address to two servers. That can happen. I'm talking about join. Suppose table 1 is on this table and table 1 is on this table, this machine. Table 2 is on this machine and this machine and this machine. Okay, and table 3 is on this machine. If you want to do the join across these three tables, you'll have to make a huge amount of network calls. Okay, and the algorithm will take so first you will have to check for each one of the data in this machine. You have to check each one of the data in these three machines, and then you have to check all that row. You have to create a row for that, and then check the data for T3. So there will be like a web of machines that will cause a lot of problem if you try to do join on a horizontally scaled SQL data set. So that is the key problem, and people at um, Amazon in 2009 was running across this problem a lot. What they were doing is they were doing so many joins and their data set was so big, especially during the holiday season. The data set was so big that a simple query with one or two joins was taking around 2 minutes to run, and that was causing a lot of problem in the marketing process, and all those internal problems were happening. So they come up with a Dynamo data set. They published a paper, uh, and this data set was saying something clear. And that idea was, I'll not store my data in multiple tables. I'll keep a single table, and I'll tab all the data at that place. So, like this, customer will be a set where I save Hariharan. I'll have name as Hari Haran, and I'll have ID as say 01, and then I'll have order, and I'll have a list of books, book 1, uh, book 2, and book 3, and this will be one document that I'll save somewhere. Okay, now it's not gonna happen that always I'll try to get I'll try to do analytics on my order data. I'll just most of the time I'll just send you the customer ID, and uh, and maybe an order ID will be there. Some order ID will be there, and most of the times you will want to fetch the whole order. So order ID 23. Now order number 23, what are the books, who is the customer, and this is the data. And typically what you will do is you will have a customer table which will have a copy of this also. So two places customer will be there, and it is not necessary with NoSQL that customer here means Didn't get. Okay, Vivek, can you unmute yourself? It will be very good if you can just unmute. I'll be very happy to explain you. Otherwise, otherwise I might be running in loops. Vivek, can you unmute yourself? Sometimes Vivek gives a very good service because he helps me explain it better. So I enjoy that. Thank you, Vivek. He's here. Let me invite him.
Yes, sir.
Hello, Vivek.
Hello, sir.
So, suppose somebody comes to your shop and instead of storing the order in the order table, what I do is I create a document like this. Okay.
Okay.
And in this document, I have an order ID which is 23. I have a customer which has used me, and I save all the data related to the customer here. And I have order, which is my order here. Okay.
Okay, sir.
Now I have this is my order table. Okay. There will also be a table called as customer table, which will also have the customer data. The row in customer table will look like ID of the customer, say 01, and name of the customer, say Hariharan. Okay.
Yes, sir.
So now what is happening in order table? I am saving the join of order table with customer.
Yes.
If you go back to this example. Here what I was doing, I was having a customer table, and whenever there was an order, I was just saving the order here. Okay. Here I was only saving the order.
Yes, sir.
But now what I'm doing is, instead of just saving the order, I'm saving the join of order with customer here.
Okay, sir.
Now what I can do is, whenever I want the whole order detail, I can just do the order table lookup. I can look up into the order table and get the order. And whatever information I need for the order, I'll get it from this table itself.
Okay, sir. And how will you will copy this order, and why?
You copy this order by basically, so as soon as you insert, so suppose there is a form in which you insert who is buying. Suppose when you go to a shop, what happens, they ask you your mobile number. As soon as you give the mobile number, they fetch their database and they know who is the customer. Okay.
Yes, sir.
Once the customer is fetched from the data table of customer table, it will be sent as the request here. This customer ID 1 has bought, and these are the details of the customer. I'll send the name and the ID to the server, and the server will record that this customer, and I will also send. So I'll send the customer details and I'll send the order details, okay, to the server as the client, and the server will save in the order table the customer details and the order details together.
Okay, sir.
Okay. So let's go back to this diagram. Let's see what is happening. First, client says there is a new customer, Hariharan, who has come to the shop. Hariharan has bought 3 books. Okay. This is the knowledge with the client right now. Whoever is operating the computer on the desk knows this information. He asks Hariharan, what is your mobile number? Hariharan gives his mobile number and he queries the server for the customer detail. So the server will query the customer table in database and will return the details of this customer Hariharan to you. Okay.
Yes, sir.
Now you will have a JSON document which contains the customer ID and the name of the customer. Okay. This is with you right now. Okay. Now what you do is, along with this JSON, you create a JSON for these 3 books also. There will be a book table also, and you will just send the book ID and get the book details also. So you will get book ID, book details, maybe the ID of the book and the name of the book. Okay. And you will get those details for 3 books. Okay. Now all this information is with the client. It has got this information from the server, and now the client will send all this data back to the server, and the server will save into an order table. Okay, Vivek?
Yes, sir.
So order table will have all the details that you need to know about a particular order. You never have to do any join to get the whole order.
Yes, sir.
Okay, so
Yes,
this
sir.
will make the process very fast. This will make it a this way the process will be very fast, because uh, the whole order is at one place. Anytime you want the order, you can get it in one go. Okay,
Okay, sir.
can you think of a problem that will occur with this? Vivek, what will happen if tomorrow Hariharan comes and changes his name to Ravinder?
दिलो
What will we have to do?
Nothing, sir. If name will change, then we will get same data like using ID.
No. That is the change which will happen. So now you have three tables. One is the order table. Okay. You have the customer table, and you have the book table or book list or book table. Okay. Now, if tomorrow Hariharan says that I'm changing my name to Ravinder, then the data in the customer table has to change, and all the orders related to that customer also have a copy of that customer. You see here, I have saved a copy of that customer. Here. Hello, Vivek?
Yes, sir. Yes, sir. Yes.
Every order has a detail of the customer that has used it. So I have to change that data also.
Okay.
Now you have to go through all the orders of the customer and change those orders, and it will take some time to do it, but eventually you will do it, like it in 5 or 10 minutes you will do it. But in the customer table you can do it directly as soon as it happens, and you can say that the transaction is complete. Okay,
Yes, sir.
so now are you able to see why there will be changes of uh, Aradhya is saying, can't we just get his details? That's what I'm saying, Aradhya. And just, I'm coming back to you, Vivek. Aradhya, that's what I'm saying. You don't want to join, you don't want to keep the data at only one place. You save it at multiple copies, multiple places, and whenever you want to get the order detail, you just query one table. With this, what can happen is, it doesn't matter how many machines the order table is on, because all you are interested is in the order details. You are not interested in any joins with the order table. So every order, so first 5 orders are on this machine, next 10 orders are on this machine, 12 orders are here, 13 orders are here, and there is a machine which remembers which order is on which machine. So as soon as you say I want order ID 23, it will know it has to go to this particular machine, and it will fetch the order and return it to you. So you don't have to worry about joining tables to get the order. And that is the beauty of NoSQL databases. Okay? Sir, can't we store ID only while pushing data rather than storing name and ID together to reduce data inconsistency? Deepanshu, that is the key. If you just store the ID, when you want to get the data, you will have to do a join to get the data. You will have to do a join between two tables, and join is something you don't want to do when you are talking about a horizontal scaling. What is that machine called? Machine is database. DB server. Okay. Dipanshu, does that make sense? You don't want to save the data. You want to save all the data at one place. You want to save multiple copies, but you want to save all the data. This will have a data consistent and always. It will not have data no, the connecting machine, index. It's called index. There's a machine called as index, which will contain all the indexes of the data. Yes, Dipanshu, there will be inconsistency in data, and this is where somebody has asked me before, Karan, you have lost the connection at the wrong time. What was the last thing you have heard, Karan? Okay, so
Sir,
yeah,
sir, whenever we will take multiple copies, but when we when we will change name, Ravindra, so we want to change every time with multiple servers to change Ravindra.
Yeah. That we have to do, but that can happen offline. That don't have to happen immediately. Okay, suppose Ravinder has 5 orders, one on this table, one on this server, one on this server, and one on these 3 servers. Then what can happen? In some time, the order details will change in like 4-5 minutes. But as far as Ravinder is concerned, in the customer table, I have changed his name. Okay. This is similar to how when you click on the like button, the like has changed in one server, but it has not changed in other servers. Okay, in 4-5 minutes it will change in all the servers, like London, New York, and New Delhi. All will change the like number, but it will take some time. Okay, that is called as eventual consistency, and this is the reason why it happens. Will we create a new copy from this page again? Oh my god, Karan, I'll unmute you in few minutes and then I'll explain. Will it create a new copy? uh, it will create a new copy of customer inside the order table. Inside the order table, there will be a copy of the customer Hariharan. That's what document databases will do. Then a lot of storage is required. Yes, a lot of storage is required, colleague, but I can spread it across multiple machines. I don't have to have a big machine that contains all the. Yeah, data junk will happen. All this will happen, but data junk will happen. A lot of storage will be required. But the beauty is I can horizontally scale this database. I can have multiple machines that can have this data. Okay, colleague. So that is the trade-off you have to make. You have a beautiful database, which is SQL database that cannot scale to maybe, let's say, more than 1 million users. But now you have 3 billion users, and you have to deal with these problems. And that is where NoSQL database will come in. Karan, did you raise your hand? Do you want to raise your hand one more time? Why multiple machines? Because one machine cannot scale to infinity. One DB server cannot scale. A DB server can go to maybe 1 terabyte or maybe 2 terabyte, but you cannot have a DB server of 2 to the power 10 terabytes. I mean, that will be a huge machine, and if it goes bad, you will be lost. So what you do is you have multiple machines of 2 terabyte, and suddenly you can have like 1,000 machines of 2 terabytes each. If you are Facebook, you can have 1,000 machines of 2 terabytes each, and that is okay. Okay, that's what I was saying. You have a mic issue also. Okay, so Karan, I will explain one more time for you. So we were dealing with SQL databases, and we are looking at how SQL databases are clean and clear databases with consistency and asset property and all those things. The only problem with the SQL databases was, as soon as I try to join across multiple scaling, across horizontally scaled database, I'll get into troubles and my bill will run into infinity. To solve this problem, what I did was I saved the join itself. Whatever join I was making between customer table and book table to get the order ID. So you look here. There was an order table with book ID and customer ID. There was a book table with book details, and there was a customer table with customer detail. Whenever I want to get the details of the order for a given customer, I'll have to join the customer with the order. For each order, I'll have to join the customer table, order table, and the book table. But now what I'm going to do is, instead of doing this, I'm going to save the whole order, with the book details, with the order details, with the customer details, all of that into my order table. My order table will know the name of the customer, the ID of the customer. It will know the book details also, what all books he have bought. And I'm going to save this join directly in the order table. Now what I can do with this is I can spread the order table across multiple machines, because I know that always I will have to get the order by order ID. Whenever I give order ID, I'll get the order table. Okay. Does that make sense, Karan? Now, to make a NoSQL database, the first thing is for you to know what is the access pattern. You should know that you are going to get order ID always. Okay. You should know what is the access pattern. Are you going to get order ID, order by order ID? Are you going to get customer by customer ID? What are the key access patterns? And then you can design the database according to it. But you don't have to go into that detail. That is part of an database architect. The key point here is we use NoSQL databases because we want to scale our database to a very high level. Okay, high scale. Yeah. Now, what is DB server? DB server is this, Karan. DB server is this server which runs the DB database. So you have a server which runs the server, and there is a database server which runs the database for you. Okay. So there's a machine that stores the database. Typically, there will be multiple machines that will store your NoSQL database. Okay, Karan? Yeah, okay. So that is one. Now this is one way of storing data. Okay. This data way that I was sharing with you, the order table. This is one way of storing data, and it is called as document-based data, document-based NoSQL databases. There are multiple other ways, and we'll discuss all of them today, because after today's class, you should have a very good overview of what NoSQL databases are. The key thing that you have to remember about NoSQL databases is that data will be stored as you are storing it in your RAM instead of as you are storing it in your SQL database. Okay, that's the key point there. Now there are some points that I want to make about NoSQL databases. These databases are very simple to use. It might be looking very difficult right now, but they are very simple to use. And there is essentially no learning that you have to do. I'll say there's no learning that you have to do unless you are designing the database, which is the starting phase. There are people who are paid enormous amounts to design databases. There's this one person that I remember from DynamoDB, and he must be paid $1 million per month at least for the service he provides. But anyways, so there is some learning that you have to do, but not a steep learning curve that you have to have with NoSQL databases. They are schema less, so you don't have to worry about tomorrow if you decide that your order will not store only customer and order detail, but it will also store a coupon code. So what you can do is you can define another field in the table, and suddenly half of your data will be without coupon code and half of the data will be with coupon code. So all that schema lessness, the shamelessness of the schema lessness is there with NoSQL databases. There's not much of learning. Just think of that you are storing your JSON file into a database, and you can get the JSON file by calling an index. There can be inconsistency in your data. Data can be bad. You don't want it, but it's part and parcel of NoSQL databases. But there is something called as eventual consistency. What it means is after 4-5 minutes or maybe 1 hour, your data will be back to consistent. So sometimes you don't mind your data being inconsistent. For example, if you're running Facebook and you don't mind whether the number of likes are same in London, New York, and Delhi, it's okay if there are some inconsistencies. You can work with it. Not that many people are sitting in New Delhi and New York and communicating with each other that the likes here are 100 and the likes there are 200. So yeah. Okay, are you following so far? This is a different mindset that I want you to have. Some of these things will not make sense right now, but as you dive deep into a particular database, the best way to learn NoSQL is to learn one NoSQL database, which is what we are going to do in the next 4 lectures. And then what you can do is you can think about other databases and how they are doing it. So part of the first lecture is typically where I explain something which half of it will not make sense, but it will make sense later, and I'll uh, typically ask you to watch this lecture again after you have seen the next 4 lectures. Okay, so now when should you pick? This is a question that will come to your mind always. When should you pick a NoSQL database? There are only two conditions that I will say. First condition is consistency is not a must. Consistency is not a must. Then you can choose. And second is you need large scalability or large data set. Scalability and these two conditions are there, then you can go with NoSQL databases. That's not a problem. Sometimes people also choose NoSQL databases because easy to learn, because they don't want to worry about SQL databases and easy to learn. And this is kind of funny. I'll tell you what it is. There are NoSQL database engineers who will charge enormous amounts to companies like Amazon and Microsoft because they know how to design NoSQL databases. Uh, and then there are these Fiverr developers who will work on Fiverr and they will charge pennies to still develop MongoDB based data sets. So the huge gap is there between the people who are at the high end and people who are just starting out. And so you can learn this easily, but as you architect more and more difficult databases, you will come to realize the details of this database. Why is Postgres so popular even though it is SQL based? Okay. uh, First of all, it is open source, and second, it is a good database. There are only 4 or 5 popular databases that you will come across in SQL. One is MySQL, second is Microsoft SQL Server, and then you have Postgres, and there's one more which I'm forgetting. There's one more that you can use, and typically what happened? Oracle SQL, yes, Oracle SQL. There is Oracle. Only these few databases are there, and the GraphQL is not a SQL database. Ekta. It is not a SQL database. I'm talking about SQL databases. Graph query language is a different beast. T-SQL, those are not that famous. In the industry, people typically use these data sets, and they are only used for small scale consistent applications, banking applications, sometimes library management data sets, all those typical project like when you make a project. What about NoSQL? Yeah, I'll talk about NoSQL databases in few minutes. Now there might be a question that is coming to your mind. Scalability is okay, but what about performance? Is NoSQL going to perform better than SQL? NoSQL versus SQL? And the answer is, you remember I was talking about latency in the last lecture? There were two things I was talking about: latency and scalability. Scalability is where you want to make sure latency is constant across the scale, whereas latency is how what is the average time. And average time in NoSQL and SQL is typically the same. There won't be much difference, but it won't be. Till a point, SQL will perform at the same speed as NoSQL, or the other way around. But after some time, it will start performing. Latency is how much time a request takes. Okay. Latency is the time it takes to serve a request. That is called as latency. How late is your request? Okay. Latency wise, both of them are similar. What is the difference between SQL and NoSQL? NoSQL, NoSQL can scale, SQL cannot scale. That is the key difference. And the other difference is SQL is always consistent, NoSQL is eventually consistent. It will be eventually equal. Okay, Vivek? Those are the two key differences. There are a bunch of more differences like schema-less and small learning curve and all that. Why do you need NoSQL? Because SQL cannot scale after a point. You remember the join table I was talking about? You cannot make a join across multiple. You want to do horizontal scaling, you have to go with NoSQL. Okay? Yeah. Right now, I understand why these questions are coming up, because you don't have that much exposure to NoSQL database. No, Avijit, that is the beauty of latency. That is the beauty of NoSQL databases. There is like if you ask about DynamoDB, which is a database by Amazon, a NoSQL database, it is a beast in itself. If the requests are going above a point, it scales so well that the latency drops after a point. So latency will be like this. Initially, it will be a little high, and then slowly it drops as the number of requests increases. So NoSQL databases, they are so brilliant at scale, they shine. The latency actually drops at scale for NoSQL database. That's the beauty of engineering. That is the beauty of engineering, Hariyanan. There's a lot of engineering that goes behind the NoSQL databases. And if you have designed your NoSQL database properly, it will scale like anything. It will shine. Okay. The beauty is compliant. Yes, that is true. So, for example, DynamoDB, after a point, there's no latency. Like, there's simply no latency. It works very well. And as the more it scales, the better it performs. And the per request cost also drops after some time. So it's not like per request cost actually. Yeah, that is true. AWS charges a lot because they have developed a very good system for it. Yeah, it is a little costly, but for organizations that have that much scale, these costs are okay. How is DynamoDB different? DynamoDB is property is a private software which is very similar to MongoDB. We are going to discuss MongoDB. No, not in terms of percentage. It drops in terms of per request latency. How much time a single request takes, that is what drops. How is different? It is very similar to MongoDB. It's a document database, but they have a lot of engineering that happens behind the scene. Okay, sure. Does that answer your question, Karan? What is the graph showing? Graph is showing the time versus scale. This is the number of requests. As the number of requests increases, time per request drops, or number of requests. Does that make sense, Karan? Yeah. No, number of requests from different users. Yes, exactly. Number of requests from different users, from different places, from different clients. Everything is taken care of. And this is the part where engineering comes in picture. Now I will spend few minutes about talking about architecting this database So have you ever driven a truck, a large truck? It's very difficult to drive it, but once somebody is there, once a good driver is there, he can transfer a lot of truckload in. Archit, why did I write Archit here? Why did I write Archit? Sorry, Archit. I don't know why I write it. Yeah. Architecture. Oh, sorry. Architecture. Okay. Yeah. So this is the part about database architecture. So the people who architect the DynamoDB data structures are paid a lot because they can save a lot of server cost for you. In very little time, they can save. A well architected database is is worth every penny you spend on it. Anyways, that's the first part of today's lecture. We are going to take a short break. I'll take a shorter break today because it's been a long time I have not met you. I want to spend as much time with you. We'll meet back at 11:30. Okay, and a.m. and then we'll again discuss uh, some of the topics. Okay, some way to better that is out of the course, Avijit. I might guide you to some resources, but maybe when we discuss DynamoDB, we'll discuss it in more details. Okay. Right now, it's not part of this lecture. Right now, I'm just giving you the overview. Okay. Okay, Avijit. We'll discuss in the coming lectures probably. Hello, Avijit. That's okay or not okay? Okay.